Hi students, today we are going to discuss some important questions, examination oriented questions in chapter 2, current, electricity in physics. Now the first question is microscopic model of current and the Ohm's law. So how the question will be asked in the examination is, explain the microscopic model of current. That means you have to derive the relationship between current and drift velocity, and then based on that you will have to derive the Ohm's law in a different form. This question is very important for the slow winners. So the slow winner students are always first be thorough with this question answer in this chapter, followed by some more questions. Okay, now children, let us take a wire. Now in our home electrical wiring is done. If you observe the shape of the wire, it is cylindrical. Now a broad picture of the wire I have drawn here. It is a cylindrical shape. So let us assume this is the expanded cross section of the wire. This is the cross sectional area, circular. Okay, this is the length. So it extends from one end to the other end. So everywhere its cross section area will be the same like this. Now if it is a copper wire, means everywhere electrons, free electrons are moving from the negative terminal towards the positive terminal, is it not? So now let us assume that the right end of this wire is connected to the positive of a battery and the left end is connected to the negative of a battery. So now I have applied an electric field. So the electric field direction is always from the positive to the negative. Can you see that E is electric field? It is directed from the positive terminal to the negative terminal. Understand that first. Okay. Next, the cross section inside the entire conductor, like this, I will take a small portion like this. A small portion is called element. See, like this. So in the entire conductor, there are so many number of electrons, free electrons, and inside that I will take a small element, a portion. So naturally the electrons present in the small element will be lesser than the total. But if I divide the number of electrons in the larger volume and divide it by the larger volume, or the number of electrons in the smaller volume divided by the smaller volume, that will be a constant. That is called a number density. We have studied already number density. That is number of electrons per unit volume. Okay, that will be always constant. Keep it in mind. So here in this picture, E is electric field and A is the circular area of cross section. And inside this large conductor, a small portion I have considered, whose thickness is equal to how much? Dx. So this is the entire conductor. This is a small portion and its thickness is only dx. Okay. Now through this dx distance, some electrons are moving from the left end, that is negative end, to the right end, that is positive end. So through some distance dx, the electrons having negative charge, they are traveling towards the positive end. So with the drift velocity, this velocity only is called as drift velocity, Vd. Okay. So the picture you have to understand. Now what are all the symbols you are using in this derivation? I will explain. E is the charge of the electron, 1.6 into 10 power minus 19 coulomb. Then Vd is the drift velocity of the electron. The direction of the drift velocity is from negative to positive, that is opposite to that of the electric field. So if you want, I can rewrite this. This is the direction of the drift velocity vector. It is opposite to that of the electric field. Okay, then what is small n means? Small n is the total number of electrons divided by the total volume. So that is the number of electrons per unit volume. Okay, it is always a constant. And A is the area of cross section. Area of cross section means this circular area. Okay, everywhere it is the same. And next is E is the electric field. First you have to draw the picture, practice the diagram, show all the vectors and all quantities in the picture. Write a summary of the picture. For that 1 mark is given. Everyone can easily understand that. Now after this we have studied speed means what? Distance traveled by time taken. Is it not? Now the magnitude of the velocity or the speed is equal to the distance dx traveled by the electron in a time equal to dt. This is the first step you have to remember. Okay, right, again and again. Remember the first step, that is the starting clue for you. So, the magnitude of the velocity is equal to distance dx divided by a small time dt. Therefore, what is the dx is equal to, shift this dt to the left side. So, Vd into dt. Always keep it in mind. Keep one small dot for the product everywhere. Everywhere I have written the same. That will be easy to remember. Otherwise, it is a continuous readable word you are writing in the exam. Avoid that. Keep a dot and write the d in the suffix here. Okay. So, from this equation, dx is equal to Vd into dt. Number the equations always. So, first equation is for the distance traveled by the electron inside the conductor for a time dt. Okay, therefore this distance dx multiplied by this area will give you what? The volume of the small element, is it not? That is the next step. Volume of the small element, this small element, yes, distance, length, dx into area of cross section a into dx. So instead of dx, what shall we substitute now? Instead of this dx, Vd into dt. This is step number 2. So when you prepare sequence, you have to remember, first one is for what? Velocity expression. Then the second equation is for the volume. Okay. Now, what is the number of electrons in the small element? In this small element, how many number of electrons are present? Okay. So what is the symbol for the number of electrons in the total volume, that is small n, is it not? Small n is the number of electrons in the total volume. So n pi, that is n is the number of electrons per unit volume. If you multiply by the volume of the element, then you will get the number of electrons only in the small element. So number of electrons in the element is equal to n into volume of the element. So this is n into V. That is capital N. I am using the symbol. This is not given in the textbook. It is for my convenience, your convenience. You can introduce. So capital N is the number of electrons in the element. That is number of electrons per unit volume into V. Instead of V, we are substituting A into Vd into dt. And this is equation 3, the sequence number 3. Now, number of electrons is NaVd into dt. Do each electron, does every electron carry a charge or not? What is the charge of one electron? That is E. So, charge of one electron is what? E. Therefore, what should be the charge of capital number of n electrons? That is given by total charge in the element. Okay, total charge in the element dq. So, one charge of one electron is E. Like that, how many electrons are present? NaVd into dt, number of electrons are present. If you multiply this number of electrons by the charge of one electron, you will get the quantity of charge inside the element, that is dq. Understood? So this is n. Instead of n, I am substituting NaVd into dt. You can verify here. Equation 3 substituted here into electronic charge E. Okay. Now I bring this dt, time factor, to the left hand side. It will come as what? dq by dt. So dq by dt, rate of flow of charges. That is nothing but current. Okay. So dq by dt is equal to, leaving this dt, all other factors you write in this order, n, a, e into v drift. Okay. And this dt is not found on the right hand side, it has come to the left hand side. Okay. So this rate of flow of charges only is called as current. Understood? Therefore, I can use the symbol what? Capital I, because dq by dt is equal to I. Therefore, I is equal to NaE into V drift. This is main equation, extremely important equation. You will have to highlight it. Understand? Underline or make one box around it and highlight. This is for the examination evaluator, it is a moral booster. They will give you very good marks. So, I equal to NaE into V drift. This has to be highlighted. Equation number 4. Have you understood up to this? This is the first part of the derivation. We have derived the relationship between current and drift velocity. This itself will be asked as what? A 3-mark question in the exam. I hope you must have understood well. Now, the second step. Current density. In general, density means mass by volume, is it not? But current density means it is denoted by the symbol capital J. It is a vector quantity. Current density is a vector quantity and its direction is always along the electric field. Okay, now current density in magnitude. Okay, scalar form I have written, that is current per unit area. So instead of current, what shall we substitute now? NAE into V drift divided by A for area. So which factor get cancelled now? Area is getting cancelled. After cancelling this area, now I get J is equal to NE into V drift. Now look at the picture. Electric field and current density are from right to left, but drift velocity is from left to right. Can you see that these two vectors, J vector and V drift vector, are opposing each other, opposite direction? Therefore, now this scalar form I am rewriting in vector form. So J equal to NE into Vd. But J vector is equal to minus of NE into V drift vector. Very simple, because they are in opposite direction. On the right side I have introduced a negative sign. Okay. Already we have studied one derivation for drift velocity alone, isn't it? Drift velocity is equal to what? E by m into tau. And I am going to substitute V drift vector is equal to minus of, because V drift vector and electric field vector are also opposing each other, is it not? They are in opposite direction. Therefore, we already derived this equation. V drift is equal to minus Em by tau into E vector. So I am going to substitute this V drift here, vector form. Understand? Already there is a minus. Into another one minus is coming. Keep it in mind. Therefore, now J vector is equal to minus of N into E into, again minus of Em by tau into E. Clearly, you substitute the steps in bracket, okay? And then minus of minus will become plus. So that now J vector is equal to N. E into E is E square into tau by M into electric field. It has become positive automatically. Therefore, we get J vector is equal to one constant multiplied by E vector. Look at the bracket. Number of electrons per unit volume is a constant. The charge of the electron is a constant. This average collision time, relaxation time is constant. Mass of the electron m is also constant. Therefore, the bracketed quantity must be some constant that is denoted by the symbol sigma. Okay. So, my dear students, this equation is extremely important. That is the derivation. This is the relationship between the current density vector and the electric field vector. Understand? This only is called the microscopic form of Ohm's law. Okay. So, J equal to sigma into E. This equation number 5 to be highlighted. Okay. Is called microscopic form of Ohm's law. Here, in place of N E square tau by M, we have substituted sigma, which is a constant, and now this constant is called as the conductivity of the wire or conductor. Okay. Conductivity of the copper wire or whatever is the material. If you take the reciprocal of conductivity 1 by sigma, and it will become m divided by n e square tau. That is represented by what? The symbol rho. Rho is a familiar term for us, is it not? Rho is called as what? Specific resistance of the material, which is otherwise called as what? Resistivity. Understand that? So this equation J equal to sigma E is called as microscopic form of Ohm's law. This definitely all the slow winner students must learn and practice. Wish you best of luck.